This section is about looking at published reports and analyzing them for accuracy, and also looking at reports to see if there's any reason why the person doing the reporting might be presenting the information in that particular way. Reports published on a news site, magazines, in advertising, and I'll go ahead and add things like social media, may present data from surveys or studies. It is important to read the reports critically to determine whether the conclusions presented in the reports are valid. Consider the following. Was the survey based on a random sample? What was the size of the sample? So we've talked about sampling so far. Random sample means that they are just completely picked at random with not any sites set on a specific target or demographic. What is the size of the sample? We know that if the sample is too small, it's going to have a very large amount of error, margin of error. Could bias be introduced in conducting the survey? Could the questions be answered or asked in such a way that the presenter or the surveyor is trying to get specific answers? Was the study based on a controlled experiment with individuals randomly assigned to a control group and to a treatment group? Can a cause and effect relationship be deduced from the data? And many times you will see a correlation between two amounts of data, whether it's a positive correlation or a negative correlation. But a very common phrase in statistics is correlation is not causation. Say it with me now. Correlation is not causation. That means just because you found a correlation does not mean you have found the cause for the correlation. And I'll give you an example that is not in your textbook and not here. A few years ago, there was a large amount of storks that were being seen in this particular small European town. At the same time, the population of the town was growing quite dramatically. So there was a correlation between the number of storks in the town, and there was a correlation with the number of people that was being born in the town. So does that mean that we can conclude that the storks were bringing the babies? Obviously not. Storks don't bring babies. What really was happening was it was the opposite. Because the population was growing, there was more housing, and storks like to nest in chimneys. And being a small European town, there was a lot of chimneys, and that brought in a lot of storks. So it was not the storks causing more babies was not the reason. It was actually the higher population was causing more storks to move in. So correlation does not necessarily mean you have found causation. So real world example 1, explain whether the conclusion presented in the following report is valid. The headline is Eating Fruit Lowers Blood Pressure. The cafeteria at Midville Hospital offers a bowl of fresh fruit and other items for dessert. Researchers tracked 200 hospital employees who eat lunch in the cafeteria each day. They divided the employees into two groups, those who chose fruit for dessert and those who chose other items for dessert. At the end of 6 months, the researchers measured the blood pressure of the employees and found that those in the group that chose fruit had a lower average blood pressure than those who chose other desserts. So, is this conclusion valid from this report? Does eating fruit lower blood pressure according to this? Well, we go through and we start picking the things that were wrong with this study. First off, just starting at the top here, was the survey based on a random sample? No, it really was not based on a random sample because they targeted one specific hospital and they were not randomly assigned to a control group and a treatment group. It was just simply a group that at one point they ate fruit each day and another group ate other sweets each day or other desserts each day. So there was problems with that. What was the size of the sample? The size of the sample was 200. 200, if we follow the rule for margin of error, when we take 1 divided by the square root of 200, you get approximately 7%. So that is a fairly large margin of error, this study being based on just 200 people. Could bias be introduced in conducting the survey? Possibly. It could be that whoever was conducting this survey was trying to find a way to show a correlation between fruit eaters and lower blood pressure. So they may have particularly specifically picked this hospital because there was probably fruit eaters that the reason they ate fruit is because they had other healthy lifestyles as well, and other healthy lifestyles will keep blood pressure low as well. So that also leads us to, can a cause and effect relationship be deduced from the data? And no, it really can't, because correlation is not causation. There's probably other reasons why these employees who ate fruit, their blood pressure was low. They probably just live a generally healthier lifestyle and have low blood pressure because of it. Let's look at another one. Explain whether this conclusion presented in the following report is valid. U.S. students text less often in class than originally thought. A survey asked 450 students at Madison High School how often they sent one or more text messages while in class. Of the students surveyed, 86% said they never send a text message in class. The results of the survey show that texting in class is not a serious problem as some may have feared. So what is wrong with this headline in this study? And oh boy, where do I start on this one? The first thing is a very sensational headline. U.S. students text less often in class than originally thought. And then the study or the survey asked only 450 students of the 100 million U.S. students out there, and the 450 students were at one specific high school. So that is not a random survey. So that is the first, if you were answering this question, this is not random because of it being a specific high school and a small sample size. Only 450 students out of 100 million or so in this country. Also, how accurate was the student responses? It said 86% said they never send a text in class. I find that highly unlikely. I think the students probably, or many of them probably, were not being truthful because maybe if they thought that they would be truthful and they said, yes, we do text in class, they would probably get in trouble. So I would doubt the validity of this study. Second thing we're going to look at is identifying misleading uses of data. Data from a survey or study can be presented in a variety of ways. In some cases, the data may be presented in a graph so that someone may draw an incorrect conclusion from the data. Consider the following. Do the scales of the axes begin at 0? If not, is there a break shown in the axes? Do the scales on the axes use consistent intervals between tick marks? In other words, do they always go by 2s or always go by 5s or 10s or 20s or 100s, or does it skip around? Does part of the graph go by 2s and then part of it go by 10s and then part of it go by 100s? That's just not a very good way of making a graph. Do the scales on the axes distort differences in the data values? They might use deliberately very large data or values or very small data values on the axes. For example, maybe we're just talking about grades, which your grade is only going to go from 1 to 100 or 0 to 100. And maybe they're going by hundreds on the graph, which means everybody's bar is going to be very small and all relatively the same size. So that would not be a good way to display the grades in a class. Does a histogram group data values appropriately? I'll show you an example of that later. Does a person or organization presenting the data have a reason to create a misleading graph? And that is definitely something that can be done. Ask me sometime, if you're watching this, ask me sometime how I once presented a misleading graph to benefit something that I wanted to do many years ago. So, example 2 is explain whether the data presented in the following report is misleading. Hawks, the overwhelming choice. Students at Redwood High School are choosing a new mascot for the school's teams. A random sample of 56 students at the school were surveyed and given a choice of 4 mascots. The results shown in the bar graph indicate an overwhelming preference for Hawks and the new name for the school's teams. So you can see over there, it looks like we have a very large bar for Hawks, relatively small bars for Lions, Pandas, and Stingrays. And it looks like Hawks is double, since their bar is twice as long as Pandas, they must have double the preference for Pandas. Problem is, if you look at the scales, that's not exactly true because the scale does not start at 0, it starts at 10. and it doesn't even show the break in the axes. You know, sometimes you see this little squiggly mark to show that there's a break, that it skipped some numbers, and I don't even like the break in the axes, even if it does shown. But the actual values on this graph are 12, 14, 18, and 12. So that is not very much difference between the four examples. So the axes do not begin at 0 is one of the problems. And if I were to show the actual size of the bars, so that would be 8, 6, 4, 2, 0. So if the actual graph started at 0, these would be the size of the bars. And you can see when we start the graph at 0 that the bars are not much different in size. Yes, the Hawks does have more and a slightly larger bar, but you can see much clearly that the interval and the difference between the preferences is not much. So the axes do not begin at 0. Could the person or organization presenting the data have a reason to create misleading graphs? It is possible. It is possible that whoever's creating this graph really wants the Hawks to be the new mascot, so they purposely created a misleading graph to make it look like a large majority of the school wants, or the student body wants, Hawks as the new mascot. Last one, explain where the data presented is misleading in this one. A random sample of 10 donations received this week at the Gray Foundation show that most donations to the charity are in the $41 to $60 range. The histogram displays the data. The dollar values of the donations of the random sample are shown below. So as we see and we look at the histogram, 41 to 60 has a large majority donating that amount, $41 to $60. So that's not wrong. It's not false. It's just the way that they are grouping makes it look like there's a more or higher donation than it really is, because look at the numbers that are in that 41 to 60 range. 42, 41, 43, another 43, 41, and a 42. They are just barely in that $41 to $60 range. So this is a very misleading histogram. Is there a reason why it was done this way? Probably. It could be the Gray Foundation is trying to encourage people to make larger donations. So they purposely made a misleading graph to make it look like more people are actually donated in the $50 to $60 range, and that would encourage more people to donate the same amount as well. This is also a very small sample, a random sample of 10 donations. A random sample of 10 donations just simply is not enough to really determine a good sample for something as large as trying to get more donors.